अस्सलाम वालेकुम डियर स्टूडेंट्स। आज के लेक्चर में हम बात करेंगे प्रॉब्लम नंबर 2.5.23 जो कि हमारे जिटली वाली बुक से है और आई थिंक सी प्रॉब्लम नंबर 23 है जी। कंसिडर द सिस्टम ऑफ टोटल एंगुलर मोमेंटम J is equal to 1. We want to carry out measurement on JZ is equal to this matrices. What are the possible value will we obtain when measuring JZ? Okay, mean we have to find the eigenvalues of this matrices. Calculate average value of Gx, J square x or delta Gx if the system is in the state J is equal to minus h cut. So we will evaluate the values for J is equal to minus h cut. And repeat B for jy, j square y and delta jy. Okay. For the first, we will solve this equation and to find the eigenvalues of this equation. Okay, if we solve this matrices by obtaining its circular equation, delta jz minus lambda I is equal to 0. Jz matrix is given, minus lambda is some constant eigenvalue, I is the identity matrix. So this will give us 1 minus lambda 0 minus lambda, this should be equal to 0 for linear independence value. So this will give us eigenvalues. Lambda 1 is equal to 1 0 and 1. Okay, minus 1 0 and 1. So the values we can obtain are given as lambda is equal to minus h cut, similarly 0 and h cut. Okay, these are the possible value that we obtained. Now in the question B, we are required to record that calculate Gx, J square x and delta Gx if the system is in the J is equal to minus h cut. So first we will find in eigenvectors corresponding to it. To find the expected value of any observable J is equal to minus h, we have to find the corresponding eigenvector. In our case, the vector is Jz is equal to 0, 0, 1. Okay. No, jx is equal to, we know that jx, average value of jx is equal to jz1 bra vector, jx and jz1 column vector, because when we find the expectation value of any state vector, we can sandwich it between the two states. So jz, this is equal to a row vector corresponding to jz. If we have an eigenvector for jz which is equal to column vector, so when we convert it into bra vector, so this column vector will be converted into a row vector. Okay, just x is given, this is also given. So if we multiply this equation, this will give gx is equal to 0. Similarly, we can find the expectation values square. So this will be equal to jz, g square x and jz1. Okay, so gx square will be equal to jz1 and then gx square and jz1. This will be column vector and this will be a row vector. So multiply this gives gx square is equal to h cut square over 2. So delta gx mean deviations in findings. So that delta gx is equal to j square x minus gx square. We know that gx is equal to 0 as we already obtained, and gx is equal to this. So this will be equal to delta gx is equal to h cut over under root 2. So for the last part, the entire procedure can be now repeated for y component. In this case, jy average value is equal to jz1 jy. We will sandwich now jy between the two state eigenvectors as we are for the corresponding eigenvalues. So jz is the same jy and jz1. So you multiply this will give 0. So the average value of jy eigenvector is 0. Similarly for jy square, we will solve it for jy square. Now we will sandwich jy square between the two eigenvectors corresponding to required eigenvalues. So we will put eigen bra vectors for jz and jy square values, and similarly for jz. So we multiply this the whole term because these are the matrix and column vector, row vectors. we can multiply it by just ordinary metric multiplication method. So this will give jy square is equal to h cut square over 2. Now we have to find the delta jy, which is equal to j square y minus jy whole square. Jy is equal to 0 as we already found out, and jy square is this. So we put this values. This will give j delta jy is equal to h cut over under root 2. This is our main requirements of the questions.